I'm going to try to take a fifth root of x to the seventh. So the 5 being in the crevice of the root means take a fifth root. I'm just going to start the thing off with a tree diagram for the x to the seventh. And I'll just need 7 x's, because x to the seventh is 7 x's being multiplied together. Because it's a fifth root, we are looking for groups of 5 now, because we need to identify what could be referred to as a perfect fifth power. Okay, so we need something times itself, times itself, times itself, times itself. 5 of them. This leaves us with 2 x's who are not in a group of 5. So that means that these x's are a perfect fifth power, whereas the other x's are, I'll say, non-perfect fifth. Okay, then what you want to do is break up your radical into 2 parts, and they both have to be fifth roots, but we're going to put the x's that are in a group of 5, they would go on the left. And the 2 x's that weren't in a group of 5, they have to stay on the right. At that point, you can simplify a little bit. So we can simplify and make this into fifth root of x to the fifth. Just combine those x's into a x to the fifth, and then combine these x's into x squared. At that point, we can take a fifth root of x to the fifth. That could be done on your calculator, or you could just look at the grouping and think about what times itself 5 times makes x to the fifth. The answer is, of course, just x. So the fifth root and the fifth power cancel out. Some people will rewrite the fifth root as being a power of 1/5. That's something that could be easily entered into a calculator, and also you could use the concept of multiplying the exponents. So the 5 gets multiplied by the 1 gets multiplied by the 5, and they actually cancel out here. The 5's cancel out, leaving us with just x. But this fifth root of x squared cannot be simplified any farther, so it has to stay. That's the final answer.